Hello and Assalamualaikum. Today I will present my project to mobile application called MotherFlame Clean Energy System. This application support SDG 7 affordable and clean energy which focus on improving access to sustainable and efficient energy management. In real life situation, many households with solar system do not have a proper platform to monitor solar energy generation, track electricity consumption or access environmental information that affect energy efficiency. Most systems also lack permanent local storage, cloud synchronization and real-time environmental monitoring. Therefore, in this project, I upgrade my application by integrating room database, file-based file store, REST API integration and GPS sensor technology, together with a multi-screen Jetpack Compose navigation system. My application consists of more than 7 screens, which is 8, include login screen, home dashboard, stat screen, add energy, log screen, log list screen, community screen, location sensor and weather screen, and lastly setting screen. Navigation is handled using Jetpack Compose navigation, allowing user to move smoothly between screens. So let's move on to the app demo.
Камине в 6 утра, фотография твоя, горят воспоминания о тебе. У камина в 6 утра, разбитая душа, и все твои обещания.
For hardware sensor integration, I implemented the GPS location sensor. The application detects the user's current latitude and longitude using device location services. After obtaining the coordinates, the app automatically requests weather and solar data from the API. This makes the system dynamic because the displayed environmental data change depending on the user's real-time location. As a result, user can monitor solar potentially more accurately based on their local area. For local persistent, I implemented room database. Energy records are stored inside an entity called energy log entity, which contains information such as date, solar energy generated, energy use, nodes. The data is stored permanently on the user's device and can still be accessed even without internet connection. In my view model, the data is inserted using DAO, the insert log, new log. Meanwhile, the logs are retrieved using flow and state flow through DAO gets all log. This allows the UI to automatically update whenever new logs are added or deleted. For cloud integration, I use Firebase File Store. User can share their solar energy logs to the community board. When the share button is clicked, the log is uploaded to Firebase using community location add data. After that, the log is marked as shared locally. The shared data include username, house number, energy usage, solar generated and nodes. This information is then displayed in the community screen, allowing user to view public energy contribution from other users. This fulfills the cloud database requirement of the project. I also integrated a REST API using Reflect from the Open Meteor API. The purpose of this API is to retrieve real-time weather and solar related information. The application fetch data such as temperature, cloud cover, wind speed, solar irradiance. The API request is handled using Reflect instance, API get weather and solar function. This feature helps users understand whether weather conditions are suitable for better solar energy generation. For the code explanation, I use device GPS location sensor in location sensor screen.kt. The application first requests location information, then use get current location function to detect the user's real-time latitude and longitude. After the location is detected, the coordinates are automatically sent to the system to retrieve environmental data. For API integration, I use the Open Meteor REST API with Reflect. The implementation is defined in weather API service.kt using @get V1 forecast. The application sends the user's latitude and longitude through get weather and solar function to retrieve live weather and solar data such as temperature, cloud cover, wind speed and solar irradiance, which are then displayed on the location sensor screen. That's all from me. Thank you for watching.